thanks everyone for joining. I will not look at the number, but this is kind of a part two. Some of it builds on topics that we learned from the last webcast that I did. If you didn't watch that, totally fine. You can watch it later. You still probably will be able to follow along, especially if you do have a understanding of, kind of like fundamentals of networking. We're going to talk about 3 different methods of stealing credentials with network-based attack. Ones that are tried and true that I have used on Pentest myself. One of these things is probably going to yield some interesting information for you. If you're on the blue team side, maybe you'll get some ideas of, oh, hey, maybe I have this thing turned on and I don't know that it's turned on by default and I should, make some changes to better protect yourself as well. That being said, next slide here, we have the agenda. We're going to go over SMB Relay, I think it's like Eavesarp, because it's kind of like eavesdrop. Anyway, and then an IPv6 attack also. So first thing that we're going to go over is SMB Relays. What is SMB? SMB stands for Server Message Block. It is a network file share protocol. It is a server client protocol, and you will often see it open on port 445. So basically, a lot of SMBs use for it. It allows applications on a computer to read and write files and to request services from other server programs and a computer network. Basically, you can access files on other resources like a remote server. Now, SMB is pretty common. You will see SMB in, I don't know. I don't think there's been a network yet that I haven't seen SMB. You're probably gonna find it. That brings us to the next protocol, which is LLMNR. Maybe you've heard of this before, but it is link layer multicast name resolution. Now, when a system tries to access an SMB share, it will send a request to a DNS server, which then resolves that share name into an IP address, just as you would know with like traditional DNS. But if the DNS lookup fails and it's unable to resolve that share name, then it will send out an LLMNR request or query, and then it's going to ask any clients on the network to send information related to that share that they're trying to access. Maybe another client on the network already has knowledge of this share and can provide that information. And so this kind of happens when DNS fails. And then that brings us to NTLM, which is Windows new technology LAN manager. And it works as a challenge and response authentication protocol. I have kind of the steps here on what actions are taken. So I feel like when I read a lot of blogs or documentation, it talks about these protocols. I am far more interested in how they work. So like here, I want to talk about NTLM. So the first thing it's going to do is a client attempts to log in and a server responds with a challenge. Then the client encrypts that challenge and sends it back to the server, and that is called the challenge response. If the server can decrypt the response with the user's password hash, then you are authenticated. And that's just kind of like a high level overview, right? Now, how does all of these protocols and systems work into making a successful attack where you might be able to get credentials? And that is going to be the SMB Relay Attack. I will note there are a couple caveats to this. So if you are familiar with Nessus, the tool that, basically, I don't know, I think it's like the gold standard of vulnerability scanners. It's pretty common for anyone in pen testing. Definitely even some people that just can run Nessus in their own environments that do regular scans as things pop up. But Nessus does have a module that will list all of the clients that it has found that has, let's say, SMB message signing, like not enabled or not required. And so that kind of gives you, Nessus will give you a nice list of clients that are probably vulnerable to an SMB relay attack. So You will take that list. You can also pull out, if you don't have Nessus, you can, scan an IP range on Nmap, specifically looking for SMB signing not required. Or you could use crackmap exec crackmap exec to, look for vulnerable hosts to this. And yeah, so make sure in your environment, you do have SMB signing as required, because that mitigates this attack. But like I said, this is common. This is a common thing that we'll see. So SMB message signing is one of the processes of validating the source of requests against the system's SMB services. So when the SMB message checks are enforced, the relay attack is rendered ineffective. But it's okay if you were a pen tester, because a lot of you'll still have probably some decent success with this. So the SMB relay attack, the attacker will listen for authentication requests and then send them to the server that the attacker wants to access. The attacker will pass the exchange back and forth until the server successfully authenticates with the client, and the attacker will need to gather a list of systems that do not require SMB message validation. Let's dive in a little bit deeper into this. I have kind of a step-by-step on what you're going to do. So the first thing that you're going to want to do is gather a list of servers with SMB signing not required. Like I said, Nmap, Nessus, crackmap exec. Then step 2, I like to set up a relay on top of doing just kind of this listening on the network, listening for this traffic, these requests. So on NTLMRelayx is also a really popular tool, and it will relay capture credentials to a list of targets. That list is obviously the ones that we got from Nessus or Nmap that do not require SMB signing. And then the step 3 is you're going to set up responder. Pretty sure was maintained by Spider Labs, but now it is not maintained by them anymore, but there is a fork out there that is actively maintained. So what is responder? So when a victim tries to access an SMB drive, responder will poison that request, and the requester will be prompted for user credentials. And it basically is going to listen to this traffic, poison the messages back in these responses, and then prompt a user to, hey, like, oh, I know this SMB share. Yeah, just give me your credentials and you can have access to this SMB share. And that's how a lot of times you are able to get into having some credentials. The thing with NTLM Relay, what's nice is there's a lot of different ways you can use these tools. And I'm pretty sure we've had other webcasts just specifically on relays I know like Jordan does a lot with relays. Upon a successful relay, it will dump the SAM database of a target. So the SAM is a security account manager. It stores user accounts and security deciphers, and it will do it for all local users on the host. Oh yeah, Ryan put it in the chat. Coercions and Relays, another highly recommended webcast. And that's going to give you a little bit more details on the different flags you can use and how you can dump certain things into loot files and how you can do this as a more targeted attack. So I'd highly recommend taking this, because this is just kind of a broad overview of, how you're able to kind of use these protocols to your advantage. I put these little asterisks next here because these are very basic commands. And then, responder, you're just listening on your Ethernet port. And because it's listening for these multicast messages that it's going to try to respond to first before the actual valid, real, authentic response is able to get to the requester. That is going to be one way to gather credentials. Sometimes even too, like with just using responder, you're able to gather a lot of credentials with that. Sometimes you'll get hashes that are easier to crack than others. Sometimes you will get clear text credentials. So these are important tools that I use on every single pen test that I've been on, like with internals access to the network. The next one is also very interesting. So sometimes you're not going to be successful with the previous attack that I had mentioned. You're not going to find credentials. Maybe they've had tons of pen tests and, they are a little bit more prepared for that. In my previous webcast, we talked a little bit about ARP poisoning. This is going to be a little different, but it does rely on ARP. Eavesarp is Archangel is the username on GitHub, but it works for Kali. This is a tool that you can get on GitHub. Like I said, it works for Kali, and it identifies ARP poisoning targets. It does active discovery of SNACs, which is stale network address configuration, and it provides DNS name resolution capabilities. But please use this tool with caution. Justin Angel, thank you. That's who wrote the tool. But this is a really, really interesting tool because it does something. It works by abusing SNACs without poisoning the ARP cache of neighbors, which is good because that can sometimes lead to potential denial of service attack. So before using this tool, I would really recommend kind of researching and reviewing the information that's on GitHub, and in the comments for these slides, I had linked another tool or a really good blog post by Justin that kind of covers it a little bit more, because you really want to do this as a targeted attack. Now, what are SNACs? A little bit more. So stale network address configuration. So when a statically configured network address yields no ARP response. So you're going to have these ARP requests saying like, hey, who has this IP? Or hey, do you see this? Do you see this? Did you see this? And then there's no response back. That might indicate that the IP address is unreachable. So maybe there was changes within the network and, they didn't clean up this statically configured address. And so there's still ARP requests coming out and no responses for those. So you're going to look for, while using this tool, you're going to look for a high number of ARP requests that are for a specific IP address in a short period of time. Because once it does get a response from the ARP request, it's going to cache that. So it doesn't need to constantly be asking for the IP address. So if you see one that's like, oh, hey, I've seen this IP address being requested like 100 times within the last 10 minutes, maybe, there's a pretty good chance that it's not responding, it's not online. But this is a great opportunity for you because, well, there's a device that's looking for that IP address and it's not assigned to anybody. So you could assign it to yourself, right? If it is in the transport protocol and clear text UDP, you can assume the SNAC address and capture the traffic. It is possible to get clear text documents or other sensitive information this way, and it has been done. There are other options for TCP as well, but that does introduce some interesting problems that you can overcome. It just takes a little bit more configuration and effort. But like I said, using UDP, you can get some clear text documents that could have credentials or just sensitive information in general that you probably should not have. If you're not having success with SMB relays and things like that, maybe this is another avenue that you can take that exploits, ARP, that is a little bit safer than obviously doing like an ARP poisoning, and can provide you some really interesting information and help you, sniff out some network, like legacy network configuration that you can use to your advantage. And then later, put that on your pen test report. Or if you're blue team, you can use this tool yourself and just use an analyze feature instead of actually, assuming the IP address for one of these SNAC addresses. And you can analyze and see, hey, are there any large amount of ARP requests being sent out for IP addresses? And then go ahead and track down, maybe you can remove that configuration. That IP address no longer needs to be assigned in this static configuration. Now, IPv6. This one I'm very excited about. It's another one of those usually highly successful attack paths. I'm going to give people a little bit of a refresher on IPv6 in case you have not used it or haven't been super familiar with it. It's been a while since you've seen it. So here we go. IPv6 overview. We're just going to cover the real important stuff. So it's 128-bit addressing. It was created for IPv4 exhaustion. IPv6 takes a MAC address and network prefix provided by a local router and combines them to create a unique IPv6 address. And this is supposed to be basically like unlimited addresses. Who knows? Maybe, we never know. There are, like I said, soap dispensers that have IP addresses now. And so who knows how many IP addresses we're really going to need in the future. There's no ARP. They have neighbor solicitation and neighbor advertisements instead. Or can generate addresses using stateless address auto configuration, SLAC, or it can be signed with DHCPv6. Obviously, if they can auto configure their own routable IP addresses, what is the point of having DHCP? Well, there are still some uses for DHCP, and we'll get into those in the next couple slides. There are a couple types of addresses. With IPv4, we're used to hearing like we have broadcast and unicast, and then, there's multicast. And there are some differences between types of addresses in IPv6 and IPv4. So for unicast, we're going to have two main addresses. We're going to have the global unicast address. So this is a routable address, and the prefix can be provided by an ISP usually. And then we kind of have this down here at the bottom. You can see this is the prefix, and we have a subnet ID and then the interface ID. And that's typically how these addresses are made. And then we have a link local address. So every IPv6 host is going to have a link local address. So it's very similar to an IPv4 private address. It's used locally. It's not routable. It is required. It's automatically configured. And if you see the prefix FE80, then that would indicate it being a link local address. And it's used to reach neighbors. So a lot of neighbor communication happens between the link local address. Okay. So we have someone say, is it Ronner? That approximately 2% of my customers have active IPv6 implementations intentionally. The other 98% have IPv6 and don't manage it. So that is honestly what makes this attack a successful attack a lot of the time. So back to the IPv6 address types, we have two more. We have Anycast, which is one to nearest, and it address packets meant for multiple interfaces. And then we have Multicast, one to many, and it's delivered to all of the interfaces, and they have the prefix FF00. Those aren't as important right now, but let's talk a little bit about DHCPv6. So like I said, you can have a SLAC address, and the hosts themselves can auto-configure a routable address for themselves, but they might still need additional information other than the IP address or route. So DHCP, even with IPv4, offers a lot of information aside from just assigning an address to a host. So here, in this case, for IPv6, you might need a DNS recursive name server or a DNS domain search list. And it can be used for prefix delegation, those prefixes that are provided by the ISP that are meant to be incorporated into this address to make it routable. How can we take advantage of IPv6 to help us get information or things that we're not really supposed to have? If you look at a Windows computer here, I have the screenshot for like Wi-Fi properties, for example. IPv4 and IPv6 are automatically enabled. So what does that mean? Well, a couple things. So one, IPv6 is preferred over IPv4. A lot of people are not actually managing IPv6 or using IPv6 in their environment. However, your computer is looking for an IPv6 address because it's enabled by default. When a DHCP server in the environment might not be configured for IPv6, an attacker can listen for and respond to IPv6 requests. And the attacker can intercept all of the IPv6 traffic. This attack could potentially get authentication for a domain controller via LDAP or SMB. And I have a little graphic here, which is like the DHCPv6 Discover messages are sent out from the computer. It's being sent out to, a server over here. Maybe this is a DHCP server that is not managing IPv6 at all. But you're also going to be getting this message because these messages and requests are being sent out in a broadcast message. So you can say, hey, I just so happen to give you this, link local address that you can now communicate in IPv6. And now anytime you need to send out like a DNS request, you can just send it through me and I'll take care of it for you. So this can provide some interesting issues. We have a tool here called Man in the Middle 6. This is a tool available that you can get on GitHub. It is used for Windows only. And it does not advertise itself as the gateway. This is important because the amount of traffic that you can potentially get when you're like, hey, I'll handle all the IPv6 traffic, that can also potentially cause a denial of service attack. So you really want to be selective, very selective when you run this type of attack to make sure that you're not causing a potential denial of service. It selectively spoofs hosts, and optionally, it can send periodic router advertisements. So it can say like, hey, I'm online, and alert clients that there is a new IPv6 network. And this can trigger clients into sending a DHCPv6 request. And that can kind of just speed up the process. But honestly, like, it's optional because you are probably going to get these requests anyway. So maybe just run this in the background for a while and just see what kind of requests that you can get without needing to really solicit anything. And that's going to be a lot more quiet, right? Than just all of a sudden, hey, IPv6 is now online. And then this also works with NTLM Relay, which we had discussed in a previous side. So exploiting the default configuration of Windows to take over the default DNS server is a way to exploit. And like I said, it replies to DHCPv6 messages and provides the victim with a link local address and settings that the attacker hosts the default DNS server. I break this down a little bit further on how this is going to work. So for the full attack, step one, obviously, is a client is going to send out a broadcast request requesting IPv6 configuration via DHCPv6. The next step is going to be that using Man in the Middle 6, the attacker replies and assigns a link local address and sets the default IPv6 DNS server to the attacker's own IP address. Step 3 is that the client, after it receives this link local IPv6 address, it's going to request information on the WPAD file. I'm not sure if that's how everybody calls it, but the WPAD file. It's called Windows Proxy Auto Detection. It automatically detects a network proxy used for connecting to the internet in corporate environments. And then in 2016, Microsoft did make it a little bit harder to exploit this. So once the WPAD file is shared, the sharer of that file can request for credentials. Now, after the 2006 changes, instead of you just being able to automatically request the credentials and the client send you them happily, the client needs to be using that WPAD file. And when it opens it up and it's like using that like proxy in a web browser, then you can still use this to abuse, and get information. After you've sent them kind of like a bogus WPAD file, step 4 is you're going to use NTLMRelayx, and the attacker responds with a WPAD file where the attacker's machine is set as a proxy. So you can see as it's set as a proxy, the traffic's going to be flowing through the attacker's machine, which in some cases, like, for maybe some like HTTPS traffic, that's not really that big of a deal. I do find internally in networks, a lot of people have logins. I find this a lot. A lot of people aren't using secure SSL, TLS, or sometimes a lot of the times it's older, maybe like internal programs. And so they are actually sending credentials, clear text. But a lot of people think, oh, well, it's internally. It's not that big of a deal because, it's not outward facing. But that can still be exploited internally, and which allows me as an attacker to, one, get clear text credentials when someone signs in, but also it lets you kind of use some of the previous attacks that we had talked about in the first one, like the SMB relay, and it allows you to exploit that and gather even password hashes that can be, sometimes they can be passed, sometimes they can't, depending on what version of the hash you're getting. And then you can, use those hashes to either send them through a password cracker and decrypt, not decrypt, but you know what I mean. So anyway, I do have like a little screenshot here where it's in packets NTLM. This -6 is going to be for IPv6. So you want to make sure to include those flags as well. Like I said, NTLM, Relay, and Responder, these are fantastic tools for like network-based attacks, relays, spoofing, just honestly, such a like gold mine every time you're in a network. And then you can also dump everything out into like a loot file from this fake WPAD domain, and it'll put everything in the loot file. When the client attempts to connect to the proxy, which will require authentication, the client browser will automatically authenticate to the proxy, which is the attacker in this case. You put yourself in the middle. Then from there, the attacker can now relay the NTLM credentials to different services. These are the 3 attacks that I wanted to go over for this. There are plenty more, and I can probably do another presentation on some other network-based attacks, especially when we talk about like, I think, what is it? Like Cisco Smart Install. There's SNMP stuff that you can do, and abusing like the OIDs, gathering information that way. And then there's even some like VLAN hopping that you can attempt to do, although like a lot of, newer equipment does have some mitigations for VLAN hopping. But if you're having an unsuccessful time relaying or using Responder and getting credentials, you're just not seeing requests, sometimes you can do VLAN hopping and then find yourself on a new VLAN that has these requests that are happening that you can use Responder for to grab these hashes. Thank you for watching, everyone. That is going to be the conclusion of our part 1. If you want to go over to part 2, we are going to answer some questions by the audience and talk a little bit about our SOC. And if you have more questions, please go ahead and leave them in the comments, and then we will try and answer those as soon as we can. Thanks for watching.